Hey everybody, welcome to another episode of the PC Perspective Mailbag. I'm your host today, Ryan Schrout. Although I think last week you had somebody different. No, next week you will for sure. I don't know. You'll see. You just never know who's going to be on the show. This is where we take your questions that you submit to us. We spend 15, 20 minutes kind of answering what allotment we can get to in that time period. We get those questions from our audience either by leaving a comment on the YouTube video here or leaving a comment on PCPer.com on the post where this video is embedded. So please do that. And also, these types of videos, these extra things that we do are made possible by the Patreon campaign that we run that is at patreon.com/PCPer. So if you're interested in that, interested in supporting what we're doing and allowing us to do more of this type of stuff, please go there and help us out. So let's go ahead and get into the questions we've got this week. Sam Biscuits wants to know, I'm curious if you folks at PCPer have any idea of the age demographics of your audience. I myself am in my late 60s, and I'm wondering if there are any other geezers like me who enjoy the podcast. My wife always knows what I'm doing on Wednesday nights at 7 p.m. Pacific. That's very good. We appreciate that. It had been a while since I really focused in on the age group of our analytics. So I went through our system to take a look at this very metric. So I will say, as a late 60s, you are in the vast minority of our readers. 65 plus represents 1.66% of our audience. The largest segment, 40%, 25 to 34 years old. Probably not a surprise. But what may be a surprise is that the next most popular category at 27% or so is 35 to 44. So the younger age group, the 18 to 24, is down to 16.75%. Gives you a little bit of idea of, hey, this hobby can be more expensive. It can be on the expensive side of things. So chances are it's more difficult for someone who's 15 that's on limited budget, working their first job, what have you, or even those late teens to be able to spend, I don't know, maybe $1,000 on a video card. Now that the cryptocurrency thing was still overtaking us. But regardless of your age, we're glad that you're here, Sam, and anybody else who is watching or listening. But that was an interesting bit of information to fall back to and look to. Next question, DDD44 asks, do you know yet if the next generation NVIDIA GTX 1180, he uses in quotes, will support the HDMI 2.1 specification? I don't know the answer to that, actually. And so HDMI 2.1, like the feature highlights, and I looked up to kind of make sure we were on the same page. The feature highlights are 4K 120 support, right? So that's obviously a huge jump, or 8K 60 support. We don't have 8K monitors. We don't have 4K 120 hertz monitors yet, but we're getting there. Dynamic HDR support, ultra high speed HDMI cable, 48 gigabits per second of bandwidth, uncompressed. EARC, which is kind of the control mechanism between HDMI devices, which it's interesting. But maybe most interesting is probably why you're asking specifically about the GTX 1180 is enhanced refresh rate features like variable refresh, quick media switching, frame rate, or quick frame transport. VRR is interesting. The HDMI.org site says that it reduces or eliminates lag, stutter, and frame tearing for more fluid and better detailed gameplay. And obviously this would be in counter to G-Sync. So in theory, yes, if NVIDIA decided to support HDMI 2.1 with these products, I think they would have to support the variable refresh capability of HDMI 2.1 enabled displays. So that'll be a very interesting question to ask, whether or not NVIDIA, says we have a subset of HDMI 2.1 support because they're still trying to push back on that. But I think they knew that this was something that was coming. FreeSync being, adding adaptive, now I'm blanking on the name of it, adding in support into DisplayPort to, as they did, would that filter out to other standards? So it was an optional part of DisplayPort. It doesn't appear to be an optional part of HDMI 2.1. So we'll see, maybe by late summer. All the rumors going around now are, well, first it was going to be at GTC and then E3 and then Computex, and now it's just sometime in July. So believe whoever you want, but they will eventually come. And HDMI 2.1 will be an important question to find out. Trolling for Dollars, a frequenter of the mailbag, asks, why is the power connector for motherboard 20 plus 4 pins when there's only one 3.3 volt, one 5 volt, 12 volt, minus 12 volt, ground, and a PSU on? Same with CPU power and GPU power. I mean, the simple answer here is you want to be able to bring more amperage into the device without having to have, super thick wiring. Right? It basically allows you to bring more power into the motherboard that it can distribute across to different devices, the processor, PCIe add-in cards, mostly across that 12 volt line, right? Without having to have one really thick, high gauge device or one thick gauge wire. This breaks it up. It's easier to work with. Maybe you have a little bit of redundancy, kind of, but no, there's no magic behind it. It's really just amperage distribution across this type of system. So there you go. Brolivia Wild, which is a great name, says, I have the following drives. I have a 250 gig Samsung 840 for his OS and boot drive, 1 terabyte Samsung 850 EVO for multiplayer games, 3 terabyte Toshiba hard drive for non-competitive games and general data, 750 gig Seagate SSHD for general data. If I were to buy an X470 motherboard and Ryzen 2700X, how would StoreMI work to configure all of these drives? Ideally, I'd want to improve the load time of games on the HDD without reducing the performance I currently get out of the individually configured SSDs. So you have, first of all, hats off to your management system of your storage drives. Something I wouldn't have the patience to do, but that's good. There's a couple of ways you could do this, right? So obviously the 3 terabyte Toshiba hard drive that has your non-competitive games is what you're looking to accelerate. So that would be the drive that we'd be most interested in tying to one of the SSDs. So you've kind of got two options. One is you can actually accelerate the 3 terabyte drive with either the 250 or the 1 terabyte drive. The 1 terabyte drive, if you just stick with the free version, the included version of the InModus StoreMI implementation, you can only do up to 256 gigs of that drive as the cache. The other part would show up as a second drive letter, which maybe gets a little bit more complicated than you need. The 250 gig Samsung 840 could still be used at that cache. You could use the entirety of it as a cache. Now, the complication will be that one of these two drives, one or both of these drives, has to be kind of blown away, formatted, reconfigured. So I think the best solution is to move the data off of your 3 terabyte drive to somewhere else, right? Or if it's Steam games, delete them. You can re-download them. Move the general data that you don't have somewhere locally off someplace else. Format the 3 terabyte drive. Install your X470 motherboard. Go with your Ryzen 2700X. Install StoreMI, and then when you install the software, you have your 250 gig Samsung 840 that has the OS on it. You point it to the now empty 3 terabyte drive. It has to be empty because it has to start rearranging things on. It has to be one of the two drives has to be empty. And then once it's done its process, you can just move that data back or reinstall the games, and now it will be in its tiered storage configuration, and you will get the acceleration benefits of the StoreMI technology. The other way you could do it, which actually doesn't really save you any time, I guess, when I think about it, is that you'd have to install Windows to the 3 terabyte drive and then add an empty 250 gig SSD to the StoreMI configuration. But if you're going to install, your operating system to the 3 terabyte drive, you still have to, remove all of the data and content from it. So one thing I would point out is, because it's a good technology, we've played around with it, we like it a lot. It is still new. Make sure you're backing up your data, right? I know you've got a bunch of different drives, but make sure you're using, some kind of Backblaze or Carbonite or something to back up any of the data that is not Steam data that you can easily re-download. Just make sure you're doing that for my mind. Set my mind at ease, and it will do wonders for you as well. Kyle Bachman asks, what's the difference between 12, 10, and 7 nanometer? Is smaller better? In general, yes. The answer is smaller is better. The naming schemes of these process nodes have become slightly less useful over the last handful of years. For example, AMD built their second generation Ryzen on 12 nanometer, which in reality is just the 14 nanometer, same technology, just tweaked a little bit. The idea now is that it's the nanometer designation is supposed to represent the pitch, the distance between two components of two specific components, right? And it's not all components anymore. There are things that have to be a lot further apart. There are some things that can get closer, I guess. And that's kind of been the case, right? Basically since 20 nanometer, we've seen this kind of back and forth. In general, though, smaller is better. It's not that you can't have a hiccup along the way. 20 nanometer was that hiccup for a lot of companies, where it was easier to skip it because it didn't offer power performance improvements, didn't offer frequency improvements that people expected to see. So, with that said, 7 nanometer is going to be a really good process node from TSMC, from Samsung, and from GlobalFoundries. This is where a lot of innovation is going to happen. You're going to see new mobile processors, new high-end CPUs. You're going to have new high-end GPUs. All of that is going to come through 7 nanometer. We're going to see, I believe, a fairly significant bump in performance and capability, and maybe even power efficiency with that move. So in this case, yes, smaller will indeed be better. Question from Adnan Ahmed asks, I'm planning to upgrade my Haswell i5-based system to the newest high-end i7. Now that Intel has pushed Cannon Lake to 2019, based on historical data and your own educated guessing, how much performance difference will there be between a 14nm plus Core i7 9700K and the eventual 10nm i7 part? Honestly, this is almost an impossible question to answer. The 14nm plus 9700K type product that would exist is you're not going to see a drastic difference in clock speeds or efficiency. Right? What you may see, and I have no idea if this is true, is another increase in core speed, or in core count, I should say. Sorry. So if that's the case, then the performance difference could be pretty substantial, right? If they're going to go with an 8-core part in the traditional Z series chipset platform, then there would be performance improvements there over the 8700K that would be significant. Now, what that means for the 10nm i7 part, I have no idea. It seems more likely that there will be no 10nm desktop parts, but instead there would be 10nm plus. But if that's kind of what you were referring to anyway, the answer is still I don't know, right? The news came out that Intel's first 10nm shipping product was out. It was a laptop part. It was a 2-core non-GPU part that didn't have any particularly impressive clock speeds or power numbers or whatever, indicating that the 10nm process existing is in poor shape, which, obviously is the case because Intel has said that they basically pushed out mass production to 2019. So at this point, I'm not putting a whole lot of weight behind the move to 10nm making any drastic changes, at least in its first iteration. So that being said, if a 14nm plus part 9700K whatever comes out in a relatively short time frame, I wouldn't have any hesitance upgrading to that if that's the route you wanted to go. Right now, obviously, there's you can look at Ryzen solutions as well, but if you're sticking with Intel's high-end part, then I would still I wouldn't at this point. I think it's fairly clear at this point we shouldn't be waiting for 10nm to save our bacon on the desktop. Maybe on the mobile it will be more impressive, but for the desktop, I'd kind of just go with what you got. Another question from Dark Wizzy asks, how does read performance change as an SSD fills up? Should we ever care about the amount of free space left on a drive? You should care to some degree because when it fills up, Windows starts to have a hell of a time getting anything done. You'll get some errors that way. The answer is no, read performance shouldn't change as an SSD fills up because reading is I was going to say non-destructive, but writing's not destructive, but it doesn't impact the layout of the data on the drive. So no, I do not think read performance should ever really change as the SSD fills up. Write performance will change as SSDs fill up, especially as you get to the extreme side. Alan's done a lot of testing, and we test our SSDs at a range of capacities, even though we kind of merge it down into a weighted score. We test at, new out of the box, but steady stated, we test at like 20% full, 50% full, 90% full. And once you get above 90, things will start to slow down because it's basically got to reshuffle a whole bunch. If you're writing another big block of data to the drive, it's going to have to reshuffle a bunch of things to make space for it, right? So that is kind of a concern for write speed as SSDs fall. But for reads, I think you should be fine. Anonymous asks, do current generation SSDs still benefit in terms of performance from over-provisioning? Yes, they do. Again, especially when we get down into the write performance. Over-provisioning is used to improve that. It's also used to improve the life of the drive. So over-provisioning allows the controller to intelligently reassign blocks of flash memory to the drive as some may wear out or die or disappear for whatever reason. So over provisioning is still a thing. Even if you look at Intel's Optane drives, they have some amount of over provisioning as well. Honestly, we're not 100% sure why they need that for the type of architecture that 3D XPoint actually is. We believe it's more of a reliability thing because it is a brand new technology, and they wanted to make sure that this drive was never going to start cutting its capacity as things progress. So over provisioning is indeed still a thing. Where is Vega Discrete Mobile asks, I mean, he kind of put it right in his name, didn't he? When will Vega Discrete Mobile GPUs become available, and will they have HBM2? Vega Discrete Mobile GPUs have been announced. They've been said they were coming. We haven't really seen any yet. I expect that they will use HBM2. The Kaby Lake G part that uses mobile Vega, maybe it's Polaris type thing, is using HBM2. And I would expect you would see that being the case. Now that could, because even though HBM2 is harder to manufacture right now, it's harder to get a hold of, and that may be what's holding up these parts in general, HBM2 does offer a fairly significant power and space advantage over, GPUs that have to incorporate GDDR5 into their design, which should, in theory, make Vega perfect for a mobile implementation. It takes up less board space, uses less power. These are all fantastic things for a form factor that is small and portable. However, they just haven't materialized, and it might just be the fact that that design process is more complicated, and AMD has no reason to not sell every single discrete GPU that they can as an add-in card. So I don't know. We'll check on that. Computex is coming up here in just a couple weeks actually, and when you get the media over there in Taipei, you never know what you're going to find. So I imagine if anything's going to show up before the end of 2018, that we will see some releases or some leaks or some hidden results or whatever you want to call it of Vega Discrete for mobile implementation. All right, one more from JMC. Does the ASUS Hyper M.2 does the ASUS Hyper M.2 X16 card only work with ASUS motherboards? Would it work on the X399 Threadripper platform? I'm not interested in VROC. I just want to be able to use all of my M.2 drives in my system. The short answer to this, as I understand it, is that the ASUS card does not require you to have an ASUS motherboard, and it will work on any PCIe slot that will bifurcate. In other words, it will allow you to install a X16 card that shows up as 4x4s to the system. So you should have no issues going to any motherboard that is capable of doing that exact thing. So, yeah, I think there was another vendor that sold essentially the same type of card. Maybe it was ASRock. I can't remember who it was. Was it? Yeah, ASRock. So they're out there. They can be handy for that, but it's a very specific use case for you to look for. And make sure if you're looking at that board or the platform, and make sure you look for the capability to bifurcate. It's a very complex thing. Whatever it is. Divide the PCI Express lanes up. If you can do that, you can use these cards for the intended purpose that you want to use them with. All right, everybody, that's going to be it for this week's mailbag. Thank you for joining us. Again, if you have a question for us, next week might be Josh, could be me, could be Alan. We'll figure it out. Leave a question in the comments below in the YouTube video or on the PCPer page, and Jim will kind of look through them and figure out which ones he thinks any of us have the intelligence and capability to actually answer. Otherwise, we'll leave them in there and everybody can chat about them as well. So thank you guys again. We'll see you next week.